Hello learners, and welcome to today's lesson on linear numeric patterns, where we are going to be focusing on practice and application questions. So let's look at a few questions on numeric patterns. Considering the following numeric patterns, so we are going to now find the algebraic expression, the algebraic equation for these patterns. So let's look at the following pattern here. We have 3, 9, 15, and 21. Firstly, can we write down this pattern in words? So if we look at what is happening here, how do I move from the first number or from the first term to the next term? When you look at it, you can see that from 3 to 9, or we can also say that 9 minus 3, which is that constant difference. So we can say 9 minus 3 gives us a 6. And when we say 15 minus 9, that also gives us a 6. This means that we are adding 6 to get to the next number. When we say 21 minus 15, that also gives us a 6. So how can we describe what is happening here in words? So we can see that we are just counting in 6. So we are counting in 6s, but we started at 3. So basically that is just what is happening here. We are counting in 6s, but we have started at 3. So let's try and represent this numeric pattern in a table. So looking at the following table, we have the term number at the top. Remember, the term number just speaks to the position of the number. So that is the first position, the second position, the third position. And the term itself will be the number in the pattern. So now here we have 3 as the first term, 9 as the second term, 15 as the third term, 21 as the fourth term. And if I continue this pattern, then I will have, remember, we are counting in 6s. So if I have 21 and I add 6, then I am going to have 27. The next one being 33, and the next one being a 39. So this is me representing this numeric pattern in a table. What about the algebraic equation for this pattern? Remember, the algebraic pattern helps us have a formula so that if we are asked for bigger numbers like 20 or 30 or even 100, we can just use our formula or our equation so that we can get the answers for those terms. So now here's our table. The same way that we filled it out, we need to find the algebraic equation. Do you remember how to find the algebraic equation? Where do we start? We start by finding that constant difference. We've already spoken, the constant difference there is a positive 6, meaning we are adding 6. So when we start our formula, we are going to say Tn is equals to 6. We are going to multiply this by the term number, and then we need to find out what to add or subtract so that it gets us to 3. Let's quickly test how to do that. So we are going to first work with the first term. That is going to be 6 multiplied by 1, and then we know that gives us a 6. But how do I get to 3 from 6? Do you know how? Yes, if you are saying that we need to subtract 3, then you are absolutely correct. So that 6 multiplied by 1 is going to be 6, and then when we subtract 3, that gives us a 3. Let's just check with any term there. For now, I'll use the second term. So we are going to say 6 multiplied by 2, we know that gives us 12. But we don't need to get to 12 because we are dealing with the second term. We need to get to 9. So if I have 12, how do I get to 9? Yes, you are correct. I am going to subtract 3. So it means that from multiplying the constant difference with the term number, the extra additional thing that I need to do is to subtract 3. So this means that Tn is equals to 6n minus 3 will be our equation. What about our 20th term? Let me just write this equation here for the nth term. 6n minus 3. If I say 6 multiplied by 20, that gives us 120. And if I subtract 3, that will give me 117. What about 6 multiplied by 30? That's 180. And if I subtract 3, that is going to be 177. And if I say 6 multiplied by 100, that is going to give me 600. But if I subtract 3, that is going to give me 597. Let's look at the next example. So now I have the pattern -1, -2, -3, and -4. Do you notice that my pattern is going down in value? The numbers are becoming smaller and smaller. So this means that I am subtracting a certain value. What value am I subtracting? If you have said it is -1, then you are correct. We are subtracting a 1. So for me to get to the next one, I'm subtracting 1. And for me to get to the next one, I am subtracting 1. So what will the term number look like? Or let's start by writing the rule in words, right? So remember, what are we doing to get to the next number? We are counting backwards in ones. But we started at -1. So we are just counting in ones, but we started at -1. How will this look in a table? So we can see that the first one is -1, the second one is -2, the third one is -3, fourth one is -4. And if I continue with this pattern, then it means that the fifth one will be a -5, then the next one will be a -6, and the next one will be a -7. But now we need to find a pattern for this, or an algebraic equation for this pattern. How are we going to find that? We are looking at the pattern and we've already realized that the constant difference here is -1. So every time I am just subtracting 1. How will the general equation look like? So we know that we are going to start with a -1 and we are going to multiply by the term number. So let's look here. If we say the first term will be -1 multiplied by 1, our answer there is a -1, which is our first term. If I take the third term, for example, and I say -1, which is our constant difference, and I multiply it by 3, which is the term number, that will give us a -3. And that -3 is our term number. So it means here we are not going to add or subtract anything. We are just going to multiply the constant difference with our term number. So what does that mean for the 20th term? So that is just going to be a -20, because we are going to say -1 multiplied by 20. -1 multiplied by 30 is going to be a -30. And a -1 multiplied by 100, that is going to be a -100. Let's look at the next question. So the next question here, we are given a picture. And this picture is forming a pattern with the number of lines. The first thing that we are going to do is to continue the pattern for the next 2 pictures. So we can see that picture number 1 has 3 lines. Picture number 2 has 1, 2, 3, 4, 5, 6, 7 lines. And picture number 3 has, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. So let's look at the next picture. So you need to be very careful when you are continuing this pattern, because you need to make sure that the number of lines are increasing. And as we can see here, how many lines do we have? So when there were 5 triangles there, we had 11 lines. So we just went now and added 1, 2, 3, and 4. That means the next one is going to have 15 lines. And that last one there, let's quickly draw it. Are you counting the lines? If you found that there are going to be 19 lines, then you are absolutely correct. There are going to be 19 lines. But what is the algebraic equation going to look like? what is the constant difference between these numbers? Remember how we find the constant difference? We are going to say 7 minus 3. That gives us a positive 4. So that means we are going to say here 4 multiplied by n, and then we need to figure out what to add or subtract to get the whole equation. So we know that we're going to start by saying 4 multiplied by 1, which is 4. But our first term is 3. So if I am at 4, how do I get to 3? I am just going to subtract 1. So it means that our formula is going to say 4n minus 1. And if I quickly want to just check that, I can take perhaps the fourth term, where we are going to say 4 multiplied by 4 minus 1. And we know that our answer has to be 15 because the fourth term is 15. So what is 4 times 4? Yes, it is 16. And when I subtract 1 there, it is going to be 15, which means that this is my equation for this. And again, for the 20th term, if I need to find the answers there, you are just going to punch them into your calculator. So for the 20th term, we are just going to say there the answer is 79. For the 50th term, we are going to say the answer is 199. And for term number 200, we are going to say there 4 multiplied by 200 minus 1. That is going to give us an answer of 799. Let's quickly go to an ad break and then we'll see you just now.